We all remember science class from high school. The most fun part, of course, mixing things together, seeing things change, blowing things up, leveling a room.
I agree with you.
So That's glad that we were not in the same class.
But I didn't call the fire department on this one, so we'll keep it fairly tight. How about some color changes? Can we handle that?
I think so. I think so. This is, of course, if you don't know, Ted Keller, our science feller. Don't try this at home. I'm going to put my glasses on just in case, because I don't trust
Tom,
you.
you have a pair if you'd like, but I think it'll be okay as long as you don't like pick it up.
I won't do that.
That's right. Iodine, we know is kind of a yellowish color if we've ever tried to apply it. So Tom, I'll have you just pour a little bit of that or drop some of that. This is just plain old water that we're going to show right
Iodine in plain water.
The goal is it's not really a dropper, so shake it in there a couple of times. You can actually pour it in a little bit.
I'll do that. We'll make it easy.
Let's just go for it there. That changes it predictably yellow.
Kind of a yellow-brown, right?
Now, Shannon, if you want to come over here and pour that starch into that water and then just mix it up real quick. What we're going to show here is a chemical test. Iodine in the presence of starch, which is found in pasta and bread, will turn blue. So that's good enough. I think it's mixed well enough. So Tom, do the exact same thing this time.
I'm going to move this first.
There you go.
Get that out of the way.
So we got to pour some of that iodine in there, and we should, if we've done it right, have that change blue, saying, hey, we've got some starch in there.
Ooh, we're black.
Kind of it's black blue. So it definitely did change color.
Yeah, very deep blue, right? Like at midnight.
Yeah, one of many chemical tests you can perform to find the presence of another chemical. Now, what we're going to do is we have this
Am I done with this?
You can set that down.
Unless I cut my finger?
That's right, unless there's an accident. That's right, and we'll avoid that.
I'll move this
I've got two chemicals in here. Iodine is present, and so is starch. And what we're going to do is I just have you pour that into that one, and then back, and then leave it in one of the beakers. Go right ahead, because Shannon can do the next one.
Will this blow up?
I say there's a very small percentage of that happening.
All right, back and forth.
Oh, I'm going to stop.
Whoa!
That's all right. And that's a good enough. And then set it down. Keep the camera on that. Keep watching it. Keep watching it. And I forgot to set the stopwatch, but I timed this earlier. It should take about 11 seconds or so, give or take. And just wait for it. Wait for it.
Wait for it.
There.
Oh,
look at that.
That was
cool.
Okay, so now it's blue.
Now it's blue. So you probably did you do something wrong? Is there at first you were like, well, where's the reaction?
Right.
It took a while because we put some other ingredients in there that basically hogged the iodine molecules and waited until they were all used up. And then when all that was done, it finally reacted in the color change.
All right, so it had to get rid of the iodine molecules.
Right, it had to just kind of manipulate
All right, now let me move these over to here because I know you've got something else, right?
Now, I diluted one of the mixture. Now, Shannon, do the exact same thing on this one. This should take a little bit longer.
All right.
So these are the same ingredients,
because it's
but
diluted. Same ingredients, but we're just trying something a little bit different here. 3 should do it, and then just
She does it better than I did.
Well,
you could probably say that about
there's an art to it,
You could say that about most things,
And again,
Tom.
that one probably took just over 10 seconds.
I heard that. You didn't get by with that. No.
And there it goes, and it's already taken a little bit longer than the first one. And
but 10,
that's right, I know.
8.
Ooh,
7,
I see a little.
6,
Now, I wish I had one of those hand
4,
stopwatches you could hold,
3,
because going down to my
60 minutes.
Yes,
time.
that's right. I could have just held that right in the palm, and this is experimentation live on TV. So let's see what happens.
And
there it goes. Okay.
Yes, you could do that with your kids, couldn't you? If you knew how long it would take, and then you'd be like, "Mom's magic," and then you just like.
So by diluting it, what did it do to the iodine molecules? Just spread them more?
Right.
Or?
Basically, it just took longer for the reaction to take place.
Okay.
Right, and that's so you have a time delay. Now I want to show you. I want to give some thanks to Brian Breifogel, professor at MSU, helped me to mix some of these chemicals. He's wearing his glasses. Maybe we should have taken a hint from that. But
well, then you should have showed it before we started talking.
Well, he's got to do that.
Who got the A in chemistry here?
This is the kids don't try this at home.
Exactly. Exactly. So he helped mix the chemicals, and of course now earlier, and this was a site if you went out to get your lunch. Science feller, do not touch. I would take that advice to heart.
Science feller would probably do it. I think if it just said science feller, we know don't touch and back away from the science feller.
Obviously, I chilled that. So who wants to do that one? Just mix those two together. It's the same thing.
No, that's chilled.
Oh,
this is chilled. Most chemical reactions should go slower if the temperature
the molecular movement is always slower.
Right. The more bouncing you have, the higher temperature it is, the more quickly you're usually going to get reactions.
More active.
We'll just watch that. And while we're waiting for that, I'll tell you that this has some practical application if you ever, there's an oxidation going on in there. So OxyClean, as an example, is a way of removing stains, whether it be iodine or something else, from a fabric or whatever, and so it's not there, it goes right there. So that was in between. I expected that. That was a little bit faster than the first one, and a little bit slower than the...
But it was a little more pure solution? You didn't dilute it as much?
Same dilution as the first one, just colder.
Okay, all right.
And then if you want to clean that up and demonstrate that, this is kind
of...
Get a shot of this
one.
This is an OxyClean-like reaction. We just pour a few of those in there. And I think this is even more amazing sometimes than the actual color change. We'll just swirl that around.
And what are these? It looks very...
Yes, there it goes.
Sodium thiosulfate.
Sodium thiosulfate, which I'm told is present in small quantities in Elmer's glue, too.
So could you use Elmer's glue?
That's the topic of another science film.
I wouldn't use it to wash your clothes, although, boy, you could try.
Well, you'd only have one lump of clothes then. They'd all be glued together. You throw.
That's right. I think if we ever do a segment dedicated to Elmer's glue, we'll definitely come back to this and test
Sounds
it
like
out.
that's pretty neat, Ted.
It is pretty cool, and this is the age-old chemistry trick that is used and has fascinated people for years.
It's the kind of things you see in magic too.
Yeah, kind of neat.
I love it. Thanks a lot.
Thanks, Ted.